So let us have some questions from the previous IIT JEE questions. The question number 1. So in the following reaction sequence, the correct structure of E, F and G are. So the compound is given like this: a phenyl with a carbonyl group, this carbon is given as asterisk, and this is a carbon, a labeled carbon, either it may be a C14 or a C13 and so on, labeled carbon this is. So this compound and treatment with the heating, just heating, not any carboxylating agent, just heating. So you got a compound E. E after treatment with the iodine and NaOH, this is a iodoform giving reaction. Then you got a F and G. So the question is, what is this E, F, G are the questions. But here let us see the concept of this reaction. Generally the carbonyl group will have a polarizing effect. So therefore the compound will undergo a breakage of the CO2 and the carbon. So this will be given like this, and the hydrogen is detached and CO2 will be go. The 2 electrons comes to the carbon. So it passes through the carbanion. Intermediate is a carbanion. So it is said that all the compounds which have got electron withdrawing groups will undergo this type of reaction. Firstly they will withdraw, the lone pair will come quickly, and the CO2. It passes through anion, remember. So that's why the anion formed here will have a resonance stabilization with this one. And we have another feature also. This is called a beta keto acid. Actually a long chain, if it is there, a halogen or any withdrawing group, closer the one which should be the helpful for the decarboxylation. But a keto here, let us say if a keto is there on the alpha carbon, anion is formed on the keto itself, a carbonyl group and an anion, that is not any resonance stabilized. But whereas the keto is on the beta, if this becomes anion, the anion will be showing the resonance with this keto. So therefore beta keto acids have got a special case of this easy of the decarboxylation. That's why only on heating CO2 will be lost. The E will be the phenyl with C double bond O and the CH3. The formation of this also explained in other way also. If a beta keto is there like this, there is a 6-membered ring formation. Once in an IIT exam also asked, explain how the beta keto acids undergo easy decarboxylation. So if this the electrons are withdrawn like this, this goes into a CO2, and these 2 electrons will come here, and this double bond will go here and catch this hydrogen. So temporarily a compound with OH is formed, which is a enol. This CO2 will be out, however. This hydrogen will be there at here, and it shows tautomerization. The hydrogen comes back and gives a ketone. Thereby the beta keto acids undergo easy decarboxylation through this 6-membered ring formation. So therefore, beta keto acids on heating. Otherwise any carboxylic acids, if you want to remove CO2, you need a soda lime. But here only heating gives, so acetophenone is formed. This carbon is having a C13 labeled carbon, and the iodine CNA makes the alpha hydrogens undergo iodination, and it will cut into the CHI3. So one of the example will be CHI3, and this will have the star, and this will become a benzoic acid. So search for all these compounds. The E must be the acetophenone. F or G, one of these F or G will be the benzoic acid, one will be the iodoform, the 2 containing the labeled the carbon. So let us search see the options. E has a acetophenone, exactly right. F is a benzoic acid, but star is given on the carbonyl, that is wrong. So iodoform is there, correct, but option goes wrong. So B is also acetophenone, and benzoic acid is there, but the carbon, that is a star carbon, is on the last carbon, nowhere it is shown, isn't it? So therefore option B is wrong. Option E is so we have a star containing acetophenone, right, and we have a benzoic acid and labeled carbon is there in the iodoform, that is right. In the last option we have a almost similar, but the last G compound G is not iodoform, instead it is methyl iodide, that is the wrong answer. Answer will be the C. So that is first one is acetophenone E, F is benzoic acid, G is the iodoform. This is the iodoform reaction, the last step. So this compound undergoes iodination, alpha hydrogens undergoes iodination. This type of the alkyl substituted all methyl ketones will give this specific reaction called iodoform reaction, where iodine is used. If bromine is used, bromoform, commonly known as haloform reaction. The question number 2 appeared in the 2007 IIT JEE. So he asks, in the following reaction, it is a compound with a benzene and NHCO and the benzene. There are two benzenes are there flanking by this NHCO. So one side benzene is attached with CO group, the other side benzene is attached with the NH. It is actually called phenyl benzamide. This phenyl benzamide is treated with nitric acid and sulfuric acid. We expect a nitration reaction here, and the nitro group goes either of the benzene actually, but mononitration, if you put a condition mononitration, the nitro group preferentially goes to only into the one of the benzene. So the question is which benzene undergoes this reaction. Okay. So the concept is here, whenever the benzene is having a electron donating group, a group containing a lone pair which shows a plasma effect and shows a minus 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 formation. So therefore a next electrophile, if you treat it, electrophile goes to the ortho and the para. Ortho para substituted derivatives will be formed. If a group contains a withdrawing group like a C double bond and so on, this will be withdraws like this. So the benzene undergoes a polarization out, and you will get a plus 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 at ortho para. So the electrophile goes to the not to the ortho para but goes to the meta. So therefore a meta substituted product is formed. So these two, if both the concepts are joined in this particular example, phenyl benzamide has two rings. One side a benzene with the NH is there, the other side CO is there. That means they are not two separate compounds. If two separate compounds are treated, electrophile preferential attacks in the activating and the orthopara D. But here both the compound, it is two phenyls are attached. So in this reaction, this ring is activated, this is deactivated, and this activated also goes to at ortho and para is the directing property of the lone pair. Out of the ortho and para will be the major product. So this will be the answer. The ortho nitration will have a steric hindrance. So due to the steric hindrance, the ortho product will be not taking place, only at para the reaction takes place. So such the answer in the option C. A is a nitration in the CO attached ring, that's wrong totally, and meta, okay, meta directing property, okay, but CO attached ring is not the activated one. Second option is right option, that is NH attached one, that too para reaction taking place, so B is the right answer. In the C is also CO attached ring is undergone, that's wrong. In the last one again, the NH attached ring is undergone, but it is meta direction showing, so therefore it is wrong. So option B is the right answer. Answer is the B answer. That is a reaction taking place in the phenyl ring attached to the amino, that too at para position, not at ortho position. That is the concept here. Two concepts are blended in this question. It's a nice question. So the question number 3. The question is which of the following reactants on reaction with concentrated NaOH followed by acidification gives the following lactone as the only product. Lactone is a cyclic ester. That is, one side is acid, if one side is alcohol is there, automatically it will become a lactone. But here this is a carbon, with this carbon you have a, so this must be formed from the compound an acid on the one side, on the other side a CH2OH. This compound on heating will give the lactone formation. So which type of now the options, if you see carefully, which option will give this reaction means the first option we have a ester and acid, that's wrong. Second option, the acid and the aldehyde is there. So only aldehyde will undergo acid and alcohol, that is also not a perfect answer. But in the compound C, what happens? Compound C has two aldehydes. So the reason that is a reaction given here is a sodium hydroxide. When the concentrate sodium hydroxide is added, it undergoes a Cannizzaro reaction. It undergoes a Cannizzaro reaction. The reaction is one aldehyde undergoes oxidation, one undergoes reduction. So oxidation means next, that is acid. The reduction means it goes to the back chapter, that is alcohol. So one is becoming acid, the other one is alcohol. So he said it is acidification also, otherwise it will be salt. So followed by acidification means the sodium salt of the acid will become acid. So in the acidic medium, acidification is also favorable. So therefore what is happening, the acid and alcohol eliminates the water and you will get the minus of water, this lactone is formed. Okay. So therefore the option C is right. So the reaction given is here is a Cannizzaro reaction, intramolecular. Within the molecule, if the reaction, two groups are the same compound, so therefore this reaction is called intramolecular Cannizzaro reaction taking place. One group undergoes oxidation, the other one reduction, followed by esterification is also taking place. So therefore option C is the right answer. So answer C is the right answer. So let's go for the question number 4. The question is, when benzene sulfonic acid and paranitrophenol. So let us see what is benzene sulfonic acid. Benzene with the SO3H and paranitrophenol, a nitro containing phenol. These two compounds are treated with, what he says is, treated with sodium bicarbonate, or treated with sodium bicarbonate. The gases released respectively. So let us find what gases are released here. Sodium bicarbonate is a base, reacts with the little stronger acids only. Weak acids, especially if only phenol is there, this bicarbonate has no reaction. Specifically make a note that phenol will not react with the sodium bicarbonate, whereas stronger than the phenol. So nitro group is a para, which is a minus I minus M group, therefore the nitrophenol will become now a stronger acid. And the sulfonic acid is originally it is a strong acid. So both these reacts and their corresponding salts are formed. Sulfonic acid salt is formed, sodium salt of this one, and the sodium salt of the nitrophenol is formed. So what is the gas comes here means it is the gas liberated from the bicarbonate CO2. Make a note that the sulfur and OO is not given out as a sulfur dioxide. We have a misleading idea that this may liberate sulfur dioxide, this may liberate CO2, so or NO2. NO2 also may be liberated. That maybe we can have a different ideas, but in both the cases the bicarbonate is undergoing a neutralization to give the sodium salt and water formation, and CO2 will be there. In both the cases water also will be formed. So this is actual reaction. So therefore what gas is liberated? Carbon dioxide and carbon dioxide. So therefore option A here is a sulfur dioxide, NO2. We have a here NO2 is there, SO2 is there. So we may go for that option. It is wrong. NO2, SO2, NO is also wrong. Second option. The third option, SO2, CO2 is also wrong. The last answer is CO2, CO2 in both the cases, carbon dioxide. So the answer D is the right answer. Answer D is the right answer. Okay, let's go for the question number 5. The question is, 4-methyl benzene sulfonic acid reacts with sodium acetate to give. What is this 4-methyl benzene sulfonic acid? 4 means paramethyl sulfonic acid, and the other compound is sodium acetate, acetic acid, sodium salt. These are the two compounds we are added together, and we may have expect a reaction like the acetate anion may replace the SO3, because there are some reactions, sulfonic benzene when fused with potassium hydroxide, the OH replace the sulfonation, or the hydroxy group through the tosylation we remove the group. So therefore sulfonic group may give an idea, it may undergo the substitution, but here it is just a neutralization. Imagine that this compound is also acid instead of this one. If acid is there, acetic acid is there, okay, right. So from this acid and this acid, if somebody want to remove the proton, which goes first? This goes first. That means this sodium salt and this acid existing together is possible. Both the salts are possible, both acids are possible, but the combination given is not possible. That is, it is already given. Weak acid already given proton, strong acid is not given. That is the combination he is showing. So immediately what happens, the proton exchange takes place. So from the sulfonic acid to the carboxylic acid, the proton exchange takes place, and this will become the carboxylic acid, that will become the sulfonic acid, sodium salt. So methyl sulfonate with the sodium salt is formed, and this will become the acetic acid. It is not a complicated question actually, it is a very simple question. The question of neutralization reaction, the sodium salt is when compared with this one weak acid anion conjugate base is strong base. So strong base will take that proton, and that weak acid will become into the sodium salt. So therefore the 4-methyl benzene sulfonic acid on reaction gives the sodium salt of benzoic acid and the acetic acid. So the option 1 is acetic acid with sodium salt, right? That is the right answer. Answer B is sodium salt and sulfur dioxide, that is wrong. And sodium that is salt, but okay, esterification is shown, that's also wrong. Sulfur dioxide liberation, and sodium salt and sodium hydroxide acetic acid is not shown. So therefore all the other answers are wrong. Here in this reaction, it is just neutralization, acetic acid and sodium salt formation of the acid. So that is option A is the right answer. So question number 6. The question is, the product of acid hydrolysis of P and Q can be identified or distinguished by. So the two compounds are given. One is a ene attached with the an ester of the acetic acid, other side a methyl is there shown. This is compound the P. Other compound is a ene attached with a methyl and a ester of acetic acid. Both are acetic acid esters only. So in the acid hydrolysis, he is saying acid hydrolysis means water and proton. Acid hydrolysis, esterification bond at the site of the oxygen, either this side or that side breakage may take place, and you will get a enol this side. Enol, that is a 2-propanol plus acetic acid. 2-propanol plus acetic acid is the one answer. In this compound also, if you do the hydrolysis, 1-propanol will be there. 1-propanol plus acetic acid. Acetic acid is common in both the reactions. Therefore, differentiation you can't based on the acetic acid. So difference is in this compound. Now how do you differentiate? Means these compounds are unstable because they are enols. Enol will become into tautomerization into this will become into 2-propanol becomes into acetone, and 1-propanol become into the acetaldehyde. The process of exchanging this proton this side and the double bond exchanging is called a tautomerization. So this is not a resonance, it is a tautomerization phenomena, through which the H plus will be shifted here, and this O minus will become a double bond. This is polarized and the proton is accepted here. So this will become propanaldehyde. So now the entire point is, how do you differentiate an aldehyde from the ketone? So see the options given here. The A is Lucas reagent, that is used for the differentiation of alcohols 1 degree, 2 degree, 3 degree. Lucas reagent is concentrated HCl, and hydrogen zinc chloride used for the alcohols differentiation. 2,4-DNP is carbonyl compounds. Both carbonyl compounds react with 2,4-DNP. It's a common reagent. Failing solution is option C is the right answer. So answer C is the right answer. So answer D is the sodium bisulfite. Sodium bisulfite also reacts, but both gives the white color precipitate, therefore it cannot be the reason. So answer C is failing solution, which is a decolorized solution with sulfur dioxide decolorized solution, the ammonical, that is a solution of the copper sulfate. So ammonical solution of copper sulfate will contain a cuprous oxide which is precipitated as a Cu2O. Cu2O is precipitated as a red color precipitate, and which thereby we can find this color and say which is the aldehyde. Only aldehydes will give this reaction, ketones will not give this reaction. So therefore one can easily identify or differentiate the aldehyde and the ketone using the option C, that is Fehling's reagent. So let's go for the question number 7. Ethyl ester and reaction with a methyl magnesium bromide X, he said a compound P is formed. What is this ethyl ester means? He didn't mention what is this R group. Some alkyl group containing ester of a ethyl. This is mentioned. Ethyl ester of a compound is taken. What is R we don't know, but we are adding the methyl magnesium bromide. So esters and acid halides, even some extent anhydrides will undergo double reaction with the RMGX. In the first step, what happens? The methyl will add here and O will become minus. The magnesium salt will be there. When O minus comes, OET will go out. So what you will get is a ketone is formed with this methyl. So once again this methyl RMGX will add here. Second step reaction. So the RMGBr will be added. The methyl is added here. O will go become O minus. That will have a magnesium salt. So this will become on hydrolysis. What you will get is a tertiary alcohol containing the two methyls we are adding, that is one methyl, another methyl. O will become OH. This is what alcohol will come. But out of that alcohol, two alkyls we only adding, the one alkyl group which we don't know, some unknown alkyl should be there in the answer. So the product P you have to verify from the given answer. Answer A has two methyls and one methyl. That means this R may be the methyl. In such a case, two methyls we have added. So therefore trimethyl, that is type of carbinol or tertiary methyl alcohol, may be the answer. So let's go for the B option. B option has two ethyls. Two ethyls we have not added. So in the case methyl, so you will get two methyls inevitably. So therefore option B is wrong. Option C has the one methyl and two ethyls, and that's again wrong. Option C also, one ethyl is there, one propyl is there, one ethyl is there. So two ethyls. If this is a ethyl magnesium chloride, if you take this propyl, it could have become right. But answer A is the right answer. That is two methyls with one known R group. This R also, therefore we can take it as a methyl. So it is the ethyl acetate he has taken and added with RMGX. So the tertiary methyl alcohol is formed. So therefore the option A is the right answer. Answer A is the right answer. So tertiary methyl alcohol, that is option A is the right answer. So let's go for the question number 8. An enantiomerically pure acid is treated with racemic mixture of alcohol. D and L alcohols are treated having one chiral carbon. The ester formed will be, so the options are given are A optically active mixture, B pure enantiomer, C meso compound, D racemic mixture. A carboxylic acid is taken, which is a acid, let us say, otherwise acid is a, let us say, pure means let us designate as a D acid we have taken. This D acid is treated with the racemic mixture of alcohol. That means we have added the two alcohols, that is D alcohol is added and also L alcohol is also added. So a D acid is treated with the D alcohol and L alcohol. Therefore acid and alcohol will react and you will get an ester. So two types of esters are formed. What are that esters? One is D acid linked to the D alcohol, and another one is a D acid is common to both. So therefore D acid linked to the attached to the L alcohol. Questions previously asked, in fact, what is the relation between these two? It's a good question also, because the upper part is same, both are optical centers, upper part is same, lower part is a mirror image, D alcohol, L alcohol mirror. That means a part is mirror image, a part is identical. Such a type of two compounds are said to be diastereomers. In the case of D alcohol and L alcohol, you cannot separate them because they are optically active compounds. Racemic mixtures in a simple way of distillation, such methods I will not work out. So in that case, we add a pure acid, make into diastereomers. Now the relation between these two is diastereomers. Diastereomers will have a different boiling points, so different solubilities. Based on that, we are able to separate. Later, go for the hydrolysis, and you will get the pure L alcohol and D alcohol may be separated. But here the present question is, after getting the two types of the alcohols, what is the mixture formed? The mixture formed will have a, so this will have the same optical activity, isn't it? Same optical activity, but here you will have a reverse optical activity, therefore this will be cancelled, and this is same optical activity, this is cancelled, so therefore net optical activity will be 0. So the compound will have a racemic mixture whose optical activity, net optical activity is 0. So the optically active mixture is wrong. Two active compounds only, but it is opposite compounds. Pure enantiomers are wrong. They are not enantiomers, they are diastereomers. Meso compound and racemic mixture. Here the controversy is if you accept for the racemic mixture, last one, pure enantiomers, so these two must be enantiomers. Two enantiomers only will make the racemic mixture, but they are diastereomers making the racemic mixture. That is the answer. So the last answer, answer D, is the right answer. So let's go for the question number 9. The question is, this compound is a unseen compound, actually some known unknown compound, but by seeing this compound we need not to be panic. So the question is very clear. This complicated compound is treated with the 2 moles of sodamide. 2 moles of sodamide. So the answer A is given. What is that A he is asking? So the concept here is there are 4 acidic functions are there. A carbon is attached with the one side, acetylenic acidic hydrogen is there. One side a carboxylic acid is there. A benzene with the carboxylic acid. This is one acid proton. Another side only a phenol is there. This is one acidic proton. There is one acidic proton. Another acidic proton is also there. That is a phenol containing the nitro group also. So there are 4 acidic protons are there, but you have not added the 4 moles of sodamide. If 4 moles of sodamide is added, all the 4 protons will be replaced with the sodium. That is the answer. But only 2 moles are added. When 2 moles are added, what happens? The strongest acid first reacts, then the second strongest will react, third and fourth will be retained back. So if you carefully see this one, so here the what is the strongest one? Carboxylic acids are the number 1 strongest one. Then 2 are nitros are there. This is weaker one, weaker than the water actually. Acetylene proton is acidic, no doubt, but it is weaker than the water. So very mild acidic. Phenols are better acids. In the phenols also, one is nitrophenol, one is ordinary phenol. So second preference goes to this proton. Third preference goes to this question. Fourth preference goes to this proton. Now if 1 mole is added, this will be reacted and you will get a sodium salt. If 2 moles are there, this and this will be added. 3 moles, this 3, 4, all will react. Now see the answer here, 2 moles are added. In the answer A, the sodium salt of the carboxylic acid and the phenol, nitrophenol proton is removed and they have shown as a minus charges. That is the right answer, isn't it? Phenolic O minus and the acid minus. Rest other protons are there. That is the right answer. In the B and C and D, that is other type of options are given. Definitely they are wrong. So the answer is the A. So let's go for the question 10. This question, the question is benzoyl chloride is prepared from benzoic acid. Benzoyl chloride is prepared from benzoic acid by having the one of the reagent. That is, the first reagent is chlorine and the UV light. Second reagent is SO2Cl2 is known as sulfuryl chloride. Third option is SOCl2 is known as thionyl chloride. The last option is D option, chlorine and water. So chlorine and water. So no doubt all these are chlorinating agents and benzoic acid is going to become into the chlorinated product. But what is benzoic acid? Benzoic acid is benzene having a CO and the OH. Now here this OH is going to become into the chloride. If you want to chlorinate in the benzene ring, you need a chlorine and ferric chloride in the reaction. If you want to have a methyl groups outside the benzene, if you want to chlorinate it, you need a chlorine and UV light. So this is a OH2Cl means either hydroxy, that is alcohols, and the acids needs a thionyl chloride, that is SOCl2. SOCl2 is called thionyl chloride or sulfonyl chloride. This reacts with this one, gives SO plus O becomes SO2 as a byproduct. And one Cl will come with HCl will be formed. And this is a balanced equation. H and Cl, HCl, and SO and O will become SO2. The Cl will be replaced by this, the OH, you will get a benzoyl chloride. Nomenclature is also, must be very careful. It is benzoyl chloride. We have a benzyl also. Benzyl means benzene with a CH2Cl is called benzyl chloride. Benzyl chloride. Phenyl means benzene with Cl is called phenyl chloride. So the nomenclature is also must be very clear. The benzyl chloride, phenyl chloride, benzoyl chloride, all are different. We have one more chlorine compound also. Benzene with two chlorines is called benzol chloride. Benzol dichloride or benzol chloride. Three chlorines is called benzo trichloride. CCl3 is called benzo trichloride. So you should not get confused with what is benzoyl chloride. Benzoic acid on chlorination of this OH is becoming into the benzoyl chloride, for which the specific reagent is useful, thionyl chloride. That is the concept. So the answer goes to the SOCl2, that is C. So let's go for the next question, that is 11th question. The question is, when propionic acid is treated with the aqueous sodium bicarbonate, CO2 gas is liberated. The carbon of CO2 comes from. So the options given from methyl group, B carboxylic acid group, C methylene group, D bicarbonate group. So let us write the reaction here. Propionic acid is a common name of the propanoic acid, which is nothing but a common name. This propanoic acid is treated with the sodium bicarbonate, HCO3. It is a acid base neutralization, and the acid will become into the salt, CH3CH2 COO minus Na plus, and this carbon dioxide is released as a, and one H and OH forms into the H2O. So these are the three products formed in the reaction. One is sodium salt of the bicarbonate, second one is carbon dioxide, third one is water. So the bicarbonate, this carbon is there as it is. Therefore, don't expect that carbon dioxide coming from this acid. The carbon dioxide is from the bicarbonate only. So therefore, the question is very clear now. The carbon dioxide comes from the bicarbonate group. That is the option D is the right answer. So let's go for the next question, that is 12th question. The question is, hydrogenation of benzoyl chloride in the presence of palladium on barium sulfate gives a, it's a 92 question. So the option 1 is benzyl alcohol, option B is benzaldehyde, option C is benzoic acid, option D is phenol. So the benzoyl chloride means, already we have seen, a benzene containing with the COCl, right? COCl. This is treated with the hydrogen in presence of palladium supported by the barium sulfate. This particular reagent combination, palladium and barium sulfate, is known as also Lindlar's catalyst. Lindlar's catalyst. So the hydrogen will add up actually on the C double bond O and C. Initially what happens is the H and H is added, so the compound will become into C. One H is added, O will become OH and Cl, but on the same carbon OHCl will not exist. So the lone pair or the bond pair of the hydrogen will come here, and Cl, that is HCl will eliminate, you will get a benzaldehyde formation. Benzaldehyde once again reacts with the hydrogen, adding H and H, you will get the 1 degree alcohol, that is benzyl alcohol will be formed. Benzaldehyde is formed. This is a lithium aluminum hydride will give second step, otherwise the reaction will stop here only. So the second step, that is benzaldehyde will be the answer. So restricted reduction, because of the presence of the sulfur here, the reduction will be stopped at here. If in this case, if it is lithium aluminum hydride is added, the aldehyde would have reduced to continue into the primary alcohol, that is benzyl alcohol. But here what you will get is benzaldehyde. Benzaldehyde. This is a name reaction called a Rosenmund reduction. Rosenmund reduction. A popular name reaction, Rosenmund reduction it is known as. So the option B is the right answer. Next question, that is question number 13. The question is reaction of RCONH2 enamide of with a mixture of bromine and KOH gives RNH2 as the main product. The intermediates involved in the reaction are, the option A is RCONHBr, that is brominated amide. B is a RNHBr, that is brominated amine. The C is a isocyanate RNCO, and D is the both A and C. So it is a single answer. So therefore only one of that you have to choose it. So the answer goes to the, we'll see first what is the reaction actually. So what he has taken is a RCO NH2, R is not mentioned, treated with the bromine in presence of KOH. So what happens in this reaction is the bromination takes place on this one, and subsequently in the mechanism reaction RCO NHBr is formed. So this is called N-bromoamide, N-bromoamide. Even this name of the reaction is also bromamide, that is Hoffman's bromamide rearrangement. The reaction itself called Hoffman's bromoamide reaction or bromamide rearrangement reaction it is. There is a rearrangement involved. Not overall compound, but at one step we find a rearrangement. So the reaction is, the next step what happens is a KOH with alkaline medium with a K plus and the OH minus. K plus will take away Br minus and OH will take the hydrogen. So subsequently what you will get is a N with a pair and a vacant orbital and a minus charge, or a one more pair is there. So this is a electron deficient nitrogen called nitrene, acyl nitrene. This is commonly known as, the first one is called, this is an intermediate species, this is N-bromoamide. The second one is called acyl nitrene. So then this one alkyl group taking 2 electrons jumps onto this electron deficient nitrogen. So lone pair will be coming here. So make a C double bond O with double bond N with the R. This is called alkyl isocyanate. Alkyl isocyanate. So what are the 3 intermediates? One is N-bromoamide. N-bromoamide. This is first intermediate. Second intermediate is this whole group is called acyl nitrene. Acyl nitrene. And this undergoes a hydrolysis to break up here. One becomes into RNH2. So what is one compound? RNH2. The other compound this side is a carbonic acid of the potassium salt. That is K2CO3 will be the answer. Nothing but the K2CO3, potassium carbonate. So the main compound is finally what happens is CO is displaced and amine is formed. This known reaction is known as what? Hoffman's bromamide rearrangement. But now the question is, what are the intermediate formed? Means the A is right answer, RCONHBr. However, even C is also right, that is isocyanate is also right. So A and C, there is another option D containing both A and B. So therefore the D is the more correct one. So this is a single answer which you have to identify more correct. If more answers are there, out of that more correct will be the right answer. So therefore D will be the more correct than the answer B and C alone. So the answer goes to the D, which contains actually A and C. Okay. So let's go for the question. Next question, that is the 15th question. The question is, which of the following is more basic? The option A is ethanol, option B is hydrogen peroxide, option C is ethylene glycol, option D is acetic acid. So acetic acid is no doubt it is an acid, but the alcohols are taken as a water derivatives of alkylate. So R containing water and 2 are containing water. Just like the principle, ammonia is base, R containing amines are more basic because the plus I group increases the basicity. 2 R containing is much more basic, right? 2 alkyl groups. So therefore the basicity is coming down, it is increasing the basicity. Similar the case when water is and alcohol and ether is comforted. So all the alkyl group supports and alcohols will become the basic. More the alkyl groups, more basic. So in the option C is also an alcohol, but one OH acts as a minus I to the other alcohol, therefore slightly it is less basic than the, so ethyl alcohol is the right answer. So the option goes to the A. That is, ethanol is the more basic out of these 4 given compounds. So let's go the next question, that is the 15th question. Then the question is actually a compound with the amide containing a nitro group at the backside, a methyl group backside. A reaction is given, a methyl group containing CONH2, an amide with methyl group is treated with a sodium hydroxide of bromine, and that product is subsequently treated. There are 2 reactions are given. Bromine and NaOH is the first reaction. The product formed in this reaction is subsequently treated with a benzoyl chloride containing a methyl group. A methyl containing, a paramethyl containing a benzoyl chloride is added. So this is treated with this compound. So in the first step what happens is with bromine and NaOH, this gives into an amine formation. This will become into a amine formation, that is NH2 is formed. That is what in the last reaction we have seen, CO will be dismissed and the amine is formed. This amine is treated with here, so therefore hydrogen and the Cl will go out, both the compounds will join, you will get a amide formation. A benzene with NH and followed by the CO and again a benzene, and in both the benzenes we have a methyl in the amine containing benzene also. We have a methyl in the benzoyl chloride also. So you will get a paramethyl benzanilide. It is a paramethyl, and this is also paramethyl benzanilide is formed. So they search the compound which has got a amide linkage. The first one is anhydride linkage, option A. Option B is an anhydride. This is an amide, but only one side methyl is there. In the option C is an amide, but both the sides methyl. That is the right answer. In the option C we have again a imide linkage. That is wrong. So the option C is the right answer. Answer C is the right answer, which has a amide linkage and both benzenes, and both the benzenes have got the paramethyl, because we have taken a methyl benzamide treated with the paramethyl benzoyl. So both the sides methyl should be there. One side methyl is there, option B, but is wrong. So option C is having both the side methyl, so that is the right answer.